it's Mr. Duel, and today I'm going to be talking about what is chemistry and what makes up chemistry. There's actually 5 different branches, or almost kind of like departments within chemistry. Think about like a supermarket. I'm from Rochester, so I think of Wegmans, but you can think of things like Macy's or JCPenney. Every department has its own kind of specialized area, but they all kind of depend upon each other in order to get the whole store to operate. So that's kind of the way I think about chemistry. These different branches, organic, inorganic, analytical, physical, and biochem, they all kind of overlap over each other, but they do have their own specialized areas. So let's begin first with organic. I have a picture of Wegmans, actually, organic food. And if you talk to anybody on the street, the first thing they're going to say when they think of organic is food. You know, the way that food is responsibly produced, the fact that there's no pesticides or chemicals used. Well, organic food and organic chemistry are totally different things. It's a different context. So organic chemistry actually refers to the study of carbon-containing compounds. This is one of my favorite carbon-containing compounds. This is caffeine, which I depend upon every day. But you see each of these black circles are carbon atoms. And carbon is the 6th most abundant element on Earth. And later in the year, you'll also learn how reactive it actually is. It loves to bond with a lot of different types of atoms. So even though organic chemistry typically revolves around carbon-containing molecules or compounds, we see a lot of hydrogen, we see a lot of oxygen, nitrogen, phosphorus, and sulfur. And a lot of the halogens, which again you'll learn more about if you haven't already. So it's not just carbon, it's molecules that contain carbon. Typically these are non-metal molecules. Where we get into the metals are actually in inorganic, and if you're taking general chemistry or AP chemistry, you're mainly doing inorganic chemistry at that level. Inorganic is, a lot of people think, oh, hey, if organic chemistry is just carbon-containing molecules and the chemistry surrounding those types of molecules, then inorganic is non-carbon containing molecules, and that's for the most part right, but carbon is still in inorganic molecules. Inorganic molecules center around metals. So what role do metals play in biology and chemistry? And so the picture you're looking at right now is a cadmium-selenium nanoparticle. Cadmium and selenium are both metal elements. And so this is nanoparticles, which nano means very tiny. In lay terms. Also taking a look at some research into solar energy. So you see the plates on solar panels that are attracting that energy and converting it into electricity that we can use here on Earth. What actually goes into those solar panels, that's all inorganic chemistry and inorganic molecules. We get into analytical. If you've ever seen CSI or any forensic type crime drama on TV, you see them doing quite a bit of analytical chemistry. If they collect DNA samples at a crime scene and they have to determine, or maybe they have to determine what type of fiber something is, if they've collected a hair at a crime scene, that's all going to be analytical chemistry. Taking a look quantitatively, using numbers, and qualitatively, kind of describing observations, figuring out what is this substance. So analytical chemistry is used in that regard. You'll also see later on in the year that we cover a topic called oxidation reduction. And I smirked because we actually call it redox, which is just a nickname for oxidation reduction. But this is basically the chemistry of batteries. And so analytical chemistry ties into that as well. Fourth on the list is biochemistry. It might help you to think about science as a spectrum. And what I mean by that is think of large-scale science as being astronomy, right? So the study of the universe, planets, solar systems, those sorts of things. As you zoom in a little bit further from the universe, and we're just zooming into the Earth now, that's going to be geology. Meteorology falls into that, earth science. Zoom in a little bit further, and you're looking at ecosystems, that's going to be biology. And it's in this point here where we start to zoom in from biology, we actually get to the realm of chemistry. And it's in that kind of region of the spectrum between biology and chemistry that we really see biochemistry. So taking a look at DNA, polypeptides, and how these nucleic acids interact chemically. There's 21 different amino acids. One that I think you'll find familiar is W, that it's called tryptophan. And so tryptophan is, as many people know it, is found in turkey, right? But that's just one of 21 different amino acids. So we can see that there are elements. We see oxygens, we see hydrogens, we see nitrogen, and we see all these different zigzags. Those are all actually carbons. So that's, at its root, is chemistry, but it relates to biology. So that's where we get biochemistry. And then lastly, kind of zooming in from biology, you zoom in further into chemistry, and then once you're at chemistry and you zoom in even further, what you're taking a look at is really physical chemistry, or PChem, as some people call it. Physical chem talks really about quantum mechanics. It talks about thermodynamics, things that are really kind of, you have to have a really strong foundation in physics in order to understand physical chem. So one of the easiest ways to describe this is how atoms and how things that make up atoms move and how they collide. And so what I have a picture of here is a potential energy diagram, which you'll also learn about later this year, where we actually see, as a reaction takes place, the reactants forming an activated complex through heat or some sort of energy, and then eventually forming products. So you'll see more about that later on in the year. Another thing you'll see actually pretty close to the beginning of the year is nuclear chemistry. And nuclear chemistry is very controversial. We can get energy from this. We can actually also get war from it, as many of you know. So that's looking at the nucleus of an atom. That's inside of an atom, looking at the protons and neutrons. And so that's really where we get physical chemistry. So this has been a little bit of the talk of what chemistry is. Keep in mind there are 5 branches to chemistry: organic, inorganic, analytical, biochem, and physical. But they do overlap. So if you go into chemistry, you can see quite a few different pieces of it. And underneath those 5 branches, you can also see a lot of subcategories. So I hope this was helpful.